So far, we've looked at three gas laws: Boyle's Law, Charles' Law, and Gay-Lussac. Now, the next thing to do would be to put them all together in what is known as the combined gas law. So, Charles' law is volume and temperature, Boyle's is pressure and volume, and Lussac is pressure and temperature. Putting them all together, we get P times V over T being a constant. We have P times V over T1 equals P2 times V2 over T2. Combined gas law, all three together. Now, the rules for doing calculations is temperature must be in Kelvin, pressure and volume could be in any units as long as P1 and P2 are in the same unit and V1 and V2 are in the same unit. Let's do a couple of examples. A gas has a volume of 800 milliliters. That we're going to call V1, 800 milliliters. At a temperature T1 of minus 23 degrees Celsius. Those have got to be in Kelvin. So plus 273 gives us a positive 250 Kelvin. And 300 torrs, that's a pressure, 300 torr. Same thing as millimeters mercury. What would the volume of the gas be? So we're going to say V2 question mark at T2 of 227 degrees Celsius, got to be in Kelvin. So plus 273 gives us 500 Kelvin. And 600 torr, so P2 is 600 torr. All right, we are set. We need to solve for volume V2. Now, could be a little tricky here solving for V2. V2 is on the right side in the numerator. So on the left side, we're going to have P1, V1 divided by T1. Moving P2 to the other side will make it P2 on the bottom. Moving T2 to the left side, we're going to make it T2 on the top. All right, P1, 300. V1, 800. T2, 500. On the bottom, T1, 250. Also on the bottom, P2, 600. Calculator says 300 times 800 times 500 divided by 250 divided by 600. 800. 800, that's a volume, will be in milliliters. Kind of a strange answer because we end up with the same volume even though the pressure did change and the temperature did change. Both of them changing, we end up with the same volume. Let's try one more. A gas occupies volume of, so we're going to call that V1, 34.2 milliliters at a temperature, let's call it T1, 15 degrees Celsius, plus 273 is going to be 288 Kelvin. And a pressure, let's call it P1, 800 torr. What will be the pressure? So P2 equals of this gas at a standard temperature. So T2 is 0 degrees Celsius or 273 Kelvin. And a volume of 45.7. Both volumes are in milliliters. Good to go. Both pressure is in torr. And both temperatures are in Kelvin. We need to solve for P2. P2. All right. P1 or V1 over T1. P2, V2, T2. We have to solve for P2. So I'm going to move the T2 to the left side, the V2 to the left side, and I'll get P1, V1 over T1, and on the left T2, and on the bottom V2. Leaves me with P2 all by itself. Calculating P1, 800. V1, 34.2. T2, 273. Divided by T1, 288. Divided by V2, 45.7 equals, calculator says, 567.5 units torr. Torr is the same thing as millimeters of mercury. All right. So remember, temperatures must be in Kelvin. Volumes and pressures can be in any unit as long as P1 and P2 are the same and V1 and V2 are the same. And there we go, the combined law.